In the previous video, we've seen these two identities. We've done these two. In this video, we're going to look at this. So if you create yourself a circle of radius 1, and currently the angle here is x, and draw a tangent line, so this here will be 90 degrees, and this will be 90 degrees. By drawing a straight line down here and considering this small triangle here, we can see that this will always be true. And then looking at this triangle here, from here to here to here, by looking at this triangle, we can see that this is true. So to consider this, we should be looking at this triangle here, this big triangle here, this big triangle here. So don't forget this is 90 degrees because it's a tangent line. So this bit here will be 90 degrees. If this angle here is let's just work in degrees rather than radians. This angle here will be 90 take away x, because this is 90 degrees, and if this angle here is x, then this must be 90 take away x. This angle here, we're trying to work out what this angle is. Let's call it W here. So if you consider this triangle here, all the angles inside a triangle must add up to 180. So if you get this angle, which is 90 minus x, that's the first angle, plus this 90 degrees here, plus 90, and then plus this angle here, which we are trying to seek, W, it must come to 180 because of this triangle here. So now tidy this up, merge these two together, that's 180 minus x plus W. Remember, we are trying to work out W. So now, so now these two will cancel each other out. So that will be minus x plus W equals 0. Add x to both sides. So W equals x. The point is that this angle here must be x. Whatever this angle is, this angle here must be x. So hang on, let's start again. This angle here must be x. So if this angle here is x, and then we've got a right angle here. So let me just redraw this diagram. So it looks something like this. It looks something like this. This here is, well, this is our triangle here. That's a right angle there. This is our radius here. So this is our radius 1, and then we know the angle here, which is x. If this is x, then this must also be x. So now we've got a right angle triangle where we know the length and an angle. So if we know one length and one angle, we know everything there is to know about this triangle. So that means, well, what is this length here? Let's call it W, and let's try and work out W. The angle is here, so this would be tan. Hang on, let me think. Tan the angle, so tan the angle equals 1 over W. So what is W? W equals 1 over tan of x. So what is tan of x? Tan of x, remember, we've got a circle like this. Tan normally is sine x over cos x. So 1 over that would be cotangent. So going the other way would be cotangent. The point is, we've seen this in one of the earlier videos. 1 over tan x is actually cotangent of x. So this length here, from here to here, is actually cotangent of x. The next question is, what is this length here? What is this length here? So let me tidy up everything. So hang on. Okay, let's get rid of this. So what we now want to know this length here. Let's just call this length W. So now it would be, I would need to work out W. I would need to consider this. So we've got a triangle like this. So this is x. This is 1 here. So what is this length here? W. So hang on, this is x here. So to work out W, we would need to consider this, which is sine. So sine the angle equals the opposite over hypotenuse, opposite over hypotenuse. So w equals 1 over sine of x. So what is 1 over sine of x? We've seen this before. 1 over sine of x is cosecant of x. We've seen this before. So this length here is actually cosecant of x. So let me clear this up. So this length here is cot, this length here is cosecant, this length here is 1. So now we can use Pythagoras. The right angle is here, so therefore this is the hypotenuse. So the hypotenuse squared, that's this bit here, equals cotangent squared, which is this bit here, plus 1 squared, which is this thing here. So it's really us using Pythagoras to show that this is true. So by considering this triangle here, we know that this identity is true. So let's start all over again and give you a quick recap. To see why this is true, we would draw a straight line down here and consider this triangle here. By considering this triangle here, we know that this is true. To see why this is true, well, draw a tangent line. This length here, in the previous video, we said that this is tan of x, and this length here is secant of x. So, for you to memorize this, consider, well, if you look at this triangle here, this must be the longest length. This is the longest length, so this is the hypotenuse. So it will be hypotenuse squared equals, well, this thing here is tan, so tan squared and then 1 squared. So for you to memorize this, picture this in your mind. This is tan of x, this is secant of x, and this is the longest length because the right angle is here. So the longest length squared would be this, and then tan you can see, and then 1 is this. So for you to memorize this, we've seen that this is cot of x and this is cosecant of x. So for you to memorize this one here, well, don't forget the right angles here. This is the longest length. So it should be, this is the hypotenuse here. This is the hypotenuse. So this would be the hypotenuse squared, and then you've got your cot squared, and then 1 squared. So remember to memorize this, just remember that this is the longest length, which is cosecant of x, and then this is cotangent of x. So this is the hypotenuse. So that would then square it, and so on. So to memorize this, remember this bit here. This is cosecant. To memorize this, just remember that this is the longest length of the small triangle. This is secant of x. So you square the hypotenuse, which is this. Okay.